Our first task in geometry focuses on identifying a transformation. Something has occurred in this picture. I begin with triangle ABC, that's my pre-image, and I end with triangle A prime, B prime, C prime. I need to be able to identify what sort of transformation has occurred, as well as give the characteristics of that transformation. When I'm looking at this picture, I think it's a rotation, because if I notice this original, this pre-image, it looks as if it's been turned to create this new image. We're used to seeing a rotation performed at the origin, and now that we're in 10th grade math, that's not occurring anymore. So I need to be able to identify where my center of rotation is and how much my figure has been rotated, my degree of rotation. So we've learned in class how to do that it lies in the perpendicular bisector of segments that connect corresponding points. So let's go through the steps for doing that. Let's take our ruler and join segment C to segment C, point C to point C prime. This creates a segment that joins corresponding point to corresponding point. I want the perpendicular bisector of that segment. I'm operating the coordinate plane, so I know that I can identify the midpoint. That would represent the bisector part of my figure, of my segment. So from C to C prime, I have a slope of rising 4, and running 6. Let me count that and make sure. Rising 4, running 1, 2, 3, 4, 5, 6. Yes. So I went up 4 and to the right 6. Now, that was from C to C prime. So if I only want to go from C to the midpoint, I should be able to rise 2 and run 3. Notice how I halved my numerator and halved my denominator. If I go that distance, it should direct me straight to my midpoint. So I rise 1, 2, right 1, 2, and 3. So I know my midpoint is at the point -3, -2. Now that represents the bisector part of perpendicular bisector. Now I need to draw in the line that's perpendicular to CC prime and that would pass through that midpoint, taking care of the perpendicular part, making a right angle there. So once again we go back to our slope, I know that my slope was 4 over 6 or 2 over 3. So if I want the perpendicular, I would need to take the opposite reciprocal of that. So my perpendicular slope would be -3/2. I want this to stem from my midpoint. So from my midpoint, I'm going to use that perpendicular slope of -3/2. I'm going to go down 3 and to the right 2. Or I can take the negative on the bottom and move on the denominator and move up 3, left 2. And now let's join that with a line segment. I want it to pass through this point, my midpoint, and this point. Okay, so I have created my perpendicular bisector of CC prime. Now let's do the same thing for another pair of points. I'm going to follow the exact same process. Let's use a different color here. Let's say I joined A to A prime. I want to locate my midpoint, so I'm going to go down 2 and to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I went down 2, right 20. So I know my midpoint would be at halfway between those, which would be down 1 and right 10. So from point A, I go down 1, right 2, 3, 4, 5, 6, 7, 8, 9, 10. And some of us may have looked at that line and anticipated that was where my midpoint would be, but mathematically we ensured that it made sense using my slope, okay, to verify that. So from there I need to use my perpendicular rule, that if my A prime had a slope of negative 1/10, the perpendicular to that slope would have to be positive 10 over 1. I'm doing the opposite reciprocal. I'm changing the sign of the fraction, and I'm forming the reciprocal of the fraction. If I move up 10, I'm kind of going to go off my grid here. So instead of moving up 10, right 1, I'm going to move down 10, left 1, I hope. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, left 1. Oh, I've already got a point there. I will join that, creating my second perpendicular bisector. And I want to look at where the two perpendicular bisectors cross, which happened to be where I put my last point. So I just identified that my center of rotation is at the point negative 1, negative 5. That would be my center of rotation. We'll label it point X. Okay? So now I can definitively say this is a rotation at point negative 1, 5, negative 1, negative 5 of degree, and I need to figure out that degree measure. Now for me to figure out the degree measure, I'm going to have to go with a different segment. So let's erase some of these marks here, or delete some of these lines. Let's erase some of these slopes. Just make my figure a little less confusing. If I delete some of these lines and look back at my original figure, I know that my center of rotation is at the point negative 1, negative 5. So I'm going to construct some more line segments here. Let's say I take C to that point and then through the center of rotation to C prime. If I draw in that angle and then I take my protractor and I measure that angle, this will dictate my degree of rotation. Using a protractor, I need to line up my 0 degree measure at my center of rotation, turn my protractor so that one of the horizontal lines coming from that point lines up with the line that's on my protractor, and the other side of my angle will direct me to what it measures, which in this case I see that it lines up straight with 90 degrees. So I know it has a 90 degree rotation at the point negative 1, negative 5 as my center. And that's how you identify a rotation.